Hello all. In this video we're going to talk about the electromagnetic spectrum and introduce electromagnetic waves. So let's begin. An electromagnetic wave, the big difference between them and a mechanical wave is that electromagnetic waves do not require a medium. They do not need to travel through air or water or jello or glue mediums. Okay? They actually are contained in small particles called photons. And they're very, very small on the scale of protons, neutrons, and electrons. In fact, they're a little bit smaller than that. Light is an example of an electromagnetic wave. There happens to be 7 different waves and rays, depending on the amount of energy that you have, on what we call the electromagnetic spectrum. And these different types of electromagnetic waves are radio waves, microwaves, infrared rays, visible rays, ultraviolet, X-rays, and gamma rays. Okay? Frequency and wave energy are directly related. Now, if you look at the image on the screen, the more and more frequency you have, so the stuff towards the right side of this image, your X-rays and gamma rays, the wavelengths are much smaller. The crests are much closer together than at the other end of the spectrum, so radio and microwaves. Because the wavelengths are so much smaller, by definition, that means the frequency is more or increased. Remember, frequency and wavelength have an inverse relationship. So if I decrease wavelength, I have to increase frequency. The amount of wave energy contained in a ray or a wave of the electromagnetic spectrum is dependent upon its frequency. The more frequent the ray or wave is, the more energy there is. That is a direct relationship. So again, as a summary, looking at this screen, your lowest energy members of the electromagnetic spectrum would be radio and microwaves. Your highest wave energy found on the electromagnetic spectrum would be X-rays and gamma rays. Okay? The highest would be gamma. The absolute lowest would be radio waves, and everything else falls in between based off of their normal frequency and wavelength. Okay, so hopefully that makes sense. Now, you guys have already started learning a little bit about radio, microwaves, infrared rays, ultraviolet rays, X-rays, and gamma rays. You will be teaching those lessons in class very, very soon, so hopefully they're already done. I will be responsible for teaching you about visible light. Invisible light is a form of electromagnetic wave. It does not travel in a medium because none of the electromagnetic waves travel in a medium. It travels in a very, very tiny energy packets called photons. Now, whereas in sound waves, mechanical waves, amplitude on your wave scale, that y-axis on the diagrams, that represented volume. In light, as in all electromagnetic waves, amplitude represents brightness, so how bright the color is. If it's a dull green, it's not as amplified, if you will, as a very bright green. So remember, in visible light, amplitude represents brightness. Wavelength represents color. So the shorter the wavelength, a different color will be to the longer wavelength. And we'll talk about color in a separate lesson. The speed of light in a vacuum is 300 million meters per second. Now that's an awful lot faster than sound. Remember, sound is only 340 meters per second. The speed of light is 300 million meters per second. So it's almost a full 100 million meters per second faster than the speed of sound. Light travels in a straight line through a single medium. Okay, now it does not travel on that medium, it travels through it. Light will bend as it moves through a new medium. So what you can see down here to the bottom right of the screen is a prism, and a prism is just a triangular shaped device used to bend light. And the key of this whole slide and the relationship between light and a prism is that when light is shined or shown, whatever you want to call it, through a prism, that light will always, always, always bend towards the base of that prism, so the bottom of the pyramid. And we'll see this in class. But please make sure you're fully aware and understand that when light travels through a prism, it's always going to bend toward the base. And that is actually the end of our slideshow. Very brief, I know. You do have some questions to answer, so please go ahead and do that. And I will see you again in class. Bye now.